Hi there, welcome back to part 2 of Physics Light. In the first part I was talking about the space bubble concept. In my little universe, space is not a continuum, but it consists of gazillions of small bubbles, space bubbles. And in between those bubbles there are variable interbubble resistances. On this figure, represented by red, green and yellow arrows. Now this whole setup of a three-dimensional structure with variable interbubble resistances, doesn't that remind you a little of transistors and diodes in electricity? Space would more appear like a semi-intelligent digital matrix rather than a dumb analog spatial continuum. Now let's talk a little about energy. And we'll start out with simple energy forms like potential energy or kinetic energy. Again, we'll have a look at this figure, which shows a decrease in interbubble resistance between bubble 1 and bubble 5 and an increase between bubble 1 and bubble 2 due to the large mass at the bottom. That results in a potential difference between bubble 1 and bubble 5, and it drives particle A down towards bubble 5 and towards the surface of the mass. So the potential energy of this particle is correlated with the sum of all interbubble resistance changes due to gravity. And the kinetic energy correlates with the potential energy minus the energy that is being used up by the occupational interbubble resistance changes. In this little figure we have a particle B in bubble 5, and that particle B is an obstacle to particle A on its way down to the mass. It represents an occupational resistance, and it will slow particle A down on its way to the mass. In part 1 of this little presentation, I was wondering what the interference pattern might cause in the double slit experiment. Was it really due to a dual nature of particles, or was it due to a spatial effect? I was suggesting that maybe space changes under the influence of particle beams. This change in space I would like to call spatial facilitation, and it's represented on this little figure by the green arrows and the red lines. A constant flow of particles opens up certain pathways through space, which are represented by the green arrows on this figure, and it closes certain pathways in space, which are represented by the red lines. Now, if this interference pattern in the double slit experiment was due to spatial facilitation, would spatial facilitation influence gravity? Would the movement of particle A be different from the movements of particles B, C, and D following the same way at some delay? Before we come back to that question, let's first have a look at energy and light. Unless it hits a wall or is drawn in by a black hole, a light beam can travel for billions of terrestrial years without refueling. Its journey doesn't use up energy from the universe to the other one. That means in my little universe that light apparently does not have to overcome interbubble resistances when it travels through empty space. Does it have anything to do with the fact that light does not really have a mass? Not really. A comet can travel for thousands of years through empty space without refueling. And a comet certainly does have a mass. Does that mean there is no interbubble resistance without the influence of gravity and occupation? Not so. Imagine your little comet decides to speed up. It will require extra energy to overcome an extra interbubble resistance. So what's the story on interbubble resistances and moving objects? Well, this little figure represents the same comet moving from left to right at different stages. In my little universe, this comet changes the interbubble resistances in a certain zone around itself, and I call that zone the kinetic zone. As it moves from left to right, it creates a zone of decreased interbubble resistance in front of it, which is represented by the green arrow, and a zone of increased interbubble resistance at the back. This is the red arrow. This kinetic zone surrounds the particle all the time, and it moves at the same speed. There's a constant transition of green zones and red zones, and this transition does not require energy, but it creates a potential difference between back and front, and that keeps the comet running. When the comet flies at a low speed, the zone is small. When it wants to speed up, the zone needs to be increased. To increase the zone means to put in energy. Energy in my little universe is a currency that allows for trades between matter and space. So the interbubble resistance is not only dependent on mass and gravity and occupation, but also on the nature of a traveler, possibly spatial facilitation. Let's go back to our question whether there is a spatial facilitation effect when you drop a number of particles from a certain height towards a mass. Will particle D move any different from particle A due to spatial facilitation? Thinking about this, I've come up with two different scenarios. Scenario 1, the distance between A and B is so big that there is no interference of the kinetic zones. That means there is no facilitation. Scenario 2, particles A and B are so close together that there is an overlap of the kinetic zones. In that case, the green zone of particle B would weaken the red zone of particle A and vice versa. This would mean the potential difference of A and B would decrease, and this in turn would mean both A and B slow down. Is that true? I have no idea, but I sure like the things I can think.